Mabuhay. Welcome to another series of Sir Jeryl Explains. Today we will learn all about the topic law of conservation of mechanical energy. This will be lesson 2.4, so let's get right to it. Looking back, we have learned kinetic energy, being energy in motion, and potential energy, as energy of location. Both can be altered. Example is when potential energy is converted into kinetic energy, when an object experiences free fall towards the ground. Energy can be transformed in a variety of ways, so we must be familiar with all kinds of energy and how they can transform from one to the other. While energy can change forms, the total energy of a closed system is conserved, hence, the law of conservation of energy. As an object falls, potential energy is converted into kinetic energy, but the sum of the potential and kinetic energies of the object will be the same at every instant during the free fall. Since both energies are the same, we can state that mechanical energy is conserved. Example is the pendulum of a grandfather clock, which uses gravitational potential energy. At the top of the swing, the pendulum possesses maximum potential energy and zero kinetic energy. At the bottom of the swing, it possesses its minimum potential energy and its maximum potential energy. As the grandfather clock swings, these two forms interchange repeatedly. There is conservation of energy, and the total mechanical energy, which is the sum of the two, is constant. Let's try to understand the formula. Mechanical energy is equal to kinetic energy plus potential energy, or written as ME is equal to KE plus PE. Consider the following equation. This shows that the sum of the kinetic and potential energies of the system, like the pendulum, will be same at very point of its motion. Mechanical energy categorizes energy as mechanical energy includes kinetic energy and potential energy that underlies gravitational, static, etc., that are all from non-mechanical energy. Examples of these non-mechanical energy are chemical, thermal, nuclear, electrical, acoustic. These energies are also some kind of kinetic or potential energy, as they involve motion of tiny vibrating particles, the energy stored in an atomic nucleus, or energy associated with motion or storage. Energy can transform from one form to another, but it is always conserved. Example of this is a car engines converts chemical energy stored in gas through a series of steps to eventually produce kinetic energy, the movement of the car. Another example is, when we metabolize food, we are converting chemical energy within the food into the chemical energy in ATP, which can then be used as kinetic energy to move our body around. Last is, when you move around, you decide to slap your hand on the table, all your kinetic energy will be transferred into thermal and acoustic energies, which is heating up the table and then the sound. Now try on your own. Let's compute.